Is everyone here? All right, so last week we talked about, or last Friday we talked about red oaks, or specifically cherry bark oak. And I had mentioned on the very last slide the Hispidus Canker, if you remember that. And so I figured, and it's something to watch out for, you know, it commonly affects red oaks. And so I figured I would show you a very good example of a Hispidus Canker, and then we're going to talk a little bit more in depth about this pathogen. So it's kind of facing the pond if you want to swing around and get a close look really quick. So do you see these kind of thick ribs of wound wood along the edge? At some point, this would have likely have been just like a flat surface with bark covering it, and then as decay has progressed, it's formed these cavities. But this is a pretty
Just roll it, just roll it.
This is a pretty classic look for what this looks like. It can occur low on the stem, it can occur high on the stem. So it does occur occasionally on white oaks, but you're gonna see it most commonly on red oaks. So remind me really quick, what are our red oaks in this area? The most common ones? Northern red oak. Southern red oak. Willow oak, nice. Pin oak. Cherry bark oak, thank you. Scarlet oak, yeah. So those oaks with the bristle tips. So this is a fungus, and it's going to get into the tree oftentimes for like branch stubs or pruning wounds. Again, one of the reasons why we might try to avoid making pruning cuts that terminate like at the trunk, where the tree is going to take a really long time to occlude or seal up that pruning wound. That's why we might sometimes say, hey, we're only doing full branch removals up to, you know, a diameter of 4 inches, maybe less, you know, depending on the species. So this particular pathogen, it's going to invade the heartwood first, and it's going to start invading, or it's going to start its decay there, and then it will progress outward into the sapwood. Can anyone remind me what sapwood is and where on the tree that's found?
The fresh wood is on the outside of the tree.
Yeah, so is that interior or exterior to the cambium? Interior, yeah. So it's a couple annual increments just inside the cambium. So these cankers, they can be up to 12 feet long. So 3 feet to 12 feet is pretty typical. You'd see the fruiting body in the summer months, like anywhere from like summer to autumn. They're squishy, they're a little bit fuzzy. They can be orange, and then as they only persist for a single season, unlike a lot of like the conchs that you might find that are hard, they're perennial. And these will actually, they're really, really heavy, so they will sometimes fall off, and you might see them around the base of the tree. So that's really good diagnostic information. If you see these cankers and like a blackish, spongy mess like at the base, that's pretty much guaranteed to be a Hispidus canker. Then the interesting thing is, so the canker develops, or this visual heavy woundwood callus rolled with like the flat space in between. It develops relatively late, so the fungus will have already killed the sapwood and the cambium by the time the tree has put up this response. And does anyone know within, actually we'll get to that in a second. The fungus itself, like, it doesn't have a stem, so it's gonna be attached directly to the tree, because you will see in pockets of decay, you might see other weaker decay organisms that needed a more virulent pathogen to kind of get through the tree's defenses in order for them to come in. So on this tree, I've seen from this, so you can come around to this side. In fact, there's an old remnant. This is silky rosegill, which is like a really beautiful, it grows from here. It is not causing this. So just because you see a fruiting body associated with a dead spot on the tree, it doesn't mean that that mushroom, that fungus, was necessarily responsible for like the really dramatic canker in this case. So there will be sort of a succession of decay organisms. As the tree produces this woundwood, the fungus can invade the woundwood and kill that annually, and so the canker can enlarge and progress. It's one of the things that makes it a really aggressive pathogen and then is mechanically compromising the stem. So besides oaks, which I've really only ever seen it on red oaks, but it can occur on maple, birch, hickory, sweet gum, walnut, and mulberry. Again, I've only ever seen it on red oaks, typically willow oaks. And then really quick, as a primer for another lesson in the future, let's just talk about coat it really fast and why we see cankers as like long, or why we see decay as, you know, it's often most significant vertically, traveling up and down the stem more than just like encompassing the entire radius. How familiar are you guys with the what coat it is? Does anyone not know what coat it stands for? Compartmentalization of damage in trees. Just a basic description of how trees deal with damage. So there are 4 walls, and they go weakest to strongest, right? Wall 1, and this comes from the track course. Wall 1 is up and down. So the tree's response is to start plugging the xylem cells. It's the weakest wall. So if you think about decay as a column, this is why you're seeing decay travel farther up and down, because the tree is weakest defending itself along that vertical axis. So wall 2 is the late wood within each annual increment, which will try to suppress the inward spread, or in the case of heartwood, the inward to outward spread. So the late wood, it's a denser portion of the growth increment that's going to have more lignin, and the tree can alter it chemically as decay advances. So that's the next weakest of the 4 walls. So the third wall involves the rays, so the lateral spread. So can anyone tell me what rays are in wood anatomy?
They would be like the capillaries of the tree, right? They're what helps move moisture and nutrients outwards or inwards in the trunk.
Yeah, so they can move compounds like across growth increments. How would it look like in cross section?
Like going out, right?
Yeah, just kind of like outward reaching.
Yeah.
But they're sheets. We see them in cross section, and so they look like spindles, but it's a sheet, right? So it's extending up and down the tree, and so so the tree is resisting the lateral spread via these rays, which also hold parenchyma cells, which we'll get more into that when we do a lesson specifically on coat it. And then the 4th wall, which is the strongest wall, is going to be new growth. And it's chemically different, physiologically different from normal wood, chemically strong. And so that's going to be, and that's why oftentimes when you're looking at decay in cross section, you'll see it restrained to like the inner portions, and then there will be a couple inches of healthy sapwood like beyond the decay. However, in the case of Inonotus hispidus or Hispidus canker, again, it has the capacity to annually re-invade that new wound wood. But again, the tree is going to be weakest defending itself along the vertical axis. So that's why we're seeing these really long cankers. And that's why we see columns of decay, because that's how it's spreading the fastest. And the first 3 walls in track, the way that our instructor, this was really useful to me at the time, got us to try to remember it, is wall 1, wall 2, wall 3, and then wall 4. Did you remember this in talking about it?
Vaguely.
Yeah. So 1, 2, 3, 4. 1, 2, 3, 4.
Warm up. Could I offer another way?
Yeah, please.
I remembered it as 1, 2, 3, and 4.
So he's doing the little white guy in the corner dance. 1, 2, 3, 4. Yeah, so this is something that is going to mechanically weaken a tree. What do you think? How would you, if you're doing a risk assessment, we touched on this briefly last time. What is the one critical thing that's lacking in this scenario? Target. Now, Craig cares more about these geese than he does his own children. What might we say about these geese as a target?
They'll fly away.
Yeah, so there's a term that we use.
Low frequency.
Low frequency or low occupancy. So that it's the same way we might think about if you've got an ash tree that's hanging out over a semi-busy road, if you think about how long is the target within the zone of impact, like a second or less, right? Really, really brief periods of time. So even though it can look really scary, if we are thinking really pragmatically about like what those occupancy rates are, a house is a static target. A park bench, you know, below like a dead tree, one of the ways that we might mitigate risk, if we had a really otherwise beautiful red oak that had some significant Hispidus cankers and the city was having us consult and there was a park bench, we might tell them, hey, move the park bench, you know, because you're lowering that occupancy rate. So yeah, no target. And then even if the geese were really valuable targets, we'd consider those probably a target of low occupancy, not there all the time. So we think about that differently. Any questions? Have you guys seen this? Is this something that strikes you as, yeah. Have you seen it on anything other than a red oak? Always seems to be red oaks. So this is going to be the most common canker causing pathogen for oaks. And that is Hispidus canker.
Sam, how does this affect like tree work? How would this affect climbing or felling?
Like a lot of other things, you just be looking for ways to reduce the amount of impact forces that you are putting on the stem. Like I would climb a tree with Hispidus canker all day, but I'd think differently about negative rigging huge portions of the stem onto it.